All right, let's talk about local maxima and local minima of a function. By the way, maxima just means it's plural of maximum, so you could read this as local maximums, maximums, and local minimums. Right? You might want to go ahead and copy this graph into your notebook, by the way. So you could go ahead and pause the video if you like to do that. Now, one thing I wanted to point out, we do have this graph. Let's call this graph, we'll call it f of x that we're talking about. All right, these are actually points. Okay, so for example, um, this is four. This point is 4, comma 1, right? 1, 2, 3, 4, and up 1. So 4, comma 1. So we have to be really careful now that we're also using interval notation to distinguish between a point and an interval. So once again, this is a point. X coordinate is 4, y coordinate is 1. I'm not talking about right here. This is not an interval from 4 to 1. Okay. Let's talk about these local maximums and local minimums. Okay, so let me ask you this question. If I gave you this graph and I told you to circle the local maximums and circle the local minimums, um, what would you circle? Okay, so I'm just going to pause and let you think about that for a sec. Okay, um, I'm guessing for local maximums, some students picked here, here, and here. I'm gonna go back here. Let me kind of erase. I just want to make some room here. Okay, so once again, I think some of you might have picked here, here, and here. Okay, let me start color coding. Okay, so we'll use red for local maxima, and we'll use green for local minima. Okay, so I'm gonna circle the local maximums. Okay, here's one, and actually that's the only one. Okay, which might be confusing. Um, these two out here are not local maximums by definition, and we'll talk about why. All right, let's go ahead and circle the local minima. I'm gonna circle those in green. Just in your head, think of which ones you're gonna circle. Okay, so there's actually this one and this one. Okay, so it looks like we have 2 local maxima and 2 local minima. I'm sorry, one local maximum and 2 local minima. All right, let's talk about why. Let's talk about this one right here. I think this one is probably the most interesting thing to talk about. Why is this one a local maxima and why are these not? Okay, so let me zoom in. We'll focus in right here. Okay, actually, let me redraw this one bit for the sake of discussion. Okay, let me zoom out. So I'm going to draw that one bit over here. I'm kind of redrawing it up bigger so we could talk about it. Okay, so here's that point, and that's 1, comma 3 right here, just drawing it bigger, and we're saying that's a local maxima. Okay, let's talk about the definition of what a local maximum is. We're not going to look at the text yet because it's too confusing that way. So what we're going to do is we're going to pick, if we're claiming that this point, let me label it actually 1, comma 3. If we're claiming that this point is a local maximum, what we have to be able to do is we have to put an open interval around it. Let me use red for consistency. Okay, so we have to be able to place an open interval around that point do this. Okay, so here's that open interval. Okay, so we have to be able to place an open interval around the point, and if we're claiming that this point is a local maximum, anywhere else where we look in the interval, the output value of the function has to be lower. Okay, so for example, right here, the output value of the function at this point, which we're claiming is the local maximum, is 3. So is it true, if I look to the left, anywhere inside this open interval, is it true that the output is always lower? Yes. Okay, if I look to the right, is it true that everywhere in that open interval, the output value is less than 3? Yes, it is. Okay, so yes, this is an open interval. Okay. So that begs the question, why is this point over here not a local maximum? Okay, it's because of the definition. Okay, let me try. Okay, let's say we're claiming wanting to claim that this point is a local maximum. Okay, we have to be able to place an open interval around that point. Okay, so let me try to do that. Okay, so let's try to do that. Okay, so here we go. Let me try to do an open interval around that point. Okay, so here's the interval. Okay, right, I'd have to do something like this, right? Where the point falls in the interval. I can't do it because the function is not defined out here. Okay, so if I try to place an open interval around that endpoint, I just can't do it. Okay, it is true, like, well, basically the function is not defined. Okay, but just to kind of elaborate on that, I mean, if we looked over here in this area, yes, it's true that this point is greater than at a higher output value than any point over here, but over here it's not defined, so we can't say that it's the highest point, if we include something out here, because it's just not defined. Okay, I'll stop rambling on about that. So let me clean this up a little bit. All right, so what we can say is that well, let me back up a sec before I go there. Okay, let me clean this up. A little erasing here. So you could use the same argument for these 2 points over here. Let me just zoom in over here. So if we're saying that if we're claiming that this point is a local minimum, we'd have to be able to place an open interval around that point. Okay, we'd have to be able to place an open interval around that point. Here's that open interval. And we'd have to be able to show that, hey, that point has the lowest output value of any point in that interval. And that's true, right? Because if you look to the left, everything here has a higher output value than at this point and over here as well. Okay, so this is a local minimum and this is a local minimum. Okay, so here we go. Let me clean this up a little bit. All right, color that back in. Circle that again. All right. So let me kind of at this point let's do a little notation to make sure we all summarize this properly. Right, so this one over here, that was a local. I'm going to start abbreviating. This is a local max. This point over here was a local min. This one was also a local min. I'm going to switch to another color. Let's use pink. Okay, so pink. We can actually label this point something. I'm going to label this one an absolute max. I mean, if you look at the function, it is the absolute maximum value anywhere on the function. Okay, this has the highest output value right here. Where's the absolute min? Where's the absolute min? I'll give you a second to think about that. Okay, well, I think you might be looking right over here that this point, in addition to being a local min, is also an absolute min for the function. So I'm going to circle that using pink. So that is also the absolute min for the function. Okay. Well, that leaves this point out here. That point. It looks like for that point, well, we can't call it a local max or a local min because we can't place an open interval around it to confirm anything. It's also not an absolute max. It's not an absolute min. So I don't think we could call this point anything other than it's a point. All right. I think that's conceptually what you need to know. Okay, let's now go to the formal text from our textbook. Let's look at the definitions. Okay. Once again, really wordy. Okay, let's just kind of read through the first one together. Okay, here we go. I'll use bouncy dot too. Okay, a function f has a local maximum at c. That's c is a constant. If there is an open interval I containing c, so that for all x not equal to c in I, f of x is less than f of c. We call f of c a local maximum of f. That's a lot of words. All right, let's interpret that visually, okay? Because I think a lot of us are visual learners. I am one of them. Okay, so here we go. Let's say there's a function f. Okay, so let me just kind of make up something down here. Okay, there's a function f. Let's make f so that it does have a local max, okay, which occurs, let's say, right here. All right, we'll make it stop here and here. Okay, a function has a local maximum at c. At c, okay. Here we go. Let me start labeling over here. X and y, right? So c would be right here. It's a value for x. Okay, it's a value for x. If there is an open interval I containing c, let me draw that open interval. So let's put an open interval around that point. Okay, so that's I. That's our open interval from here to here. Open an interval I containing c so that for all x not equal to c in I, okay, so for any value of x not equal to c that falls in this interval, everywhere f of x is less than f of c. Okay, so let's just kind of add a little bit more to see that visually. Okay, so here's c, go dot 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 dot. Okay, out here, dot 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 dot. That is the output value of the function at c. So that's f of c over here. Okay, so what we're saying is if we pick any other x within c, let me pick one. Let me pick a value of x over here. Another value of x. Okay, so I go, let me switch colors to make it easier for you to see. Go green, dot 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 dot. Then over here, dot 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 dot. The output over here, drink this. Okay, the output over here is going to be f of x. Okay, so for this to be a local maximum, it has to be true for whatever x I pick that falls within this open interval over here. The output has to be lower. than f of c. Okay, which is true, right? If I pick any x value over here, the output's going to be lower than this right here. Okay, and it's true on this side too over here because the function's decreasing over here. We could do a similar diagram for local min, but I don't think we need to do that. Okay, I think we are going to stop right here.